Chatbots have taken the world by storm. We've never seen a technology with this kind of rapid adoption curve. In fact, it's achieved 100 million users in just the first 2 months, which is unprecedented. Well, why? It does a lot of amazing things. It uses underlying technology of generative AI, of large language models, and it does amazing stuff. One of the things I really like that I don't hear many other people talking about is language translation. In fact, either direction. And I need this a lot, porque mi español es muy malo. But if you have a translation that's able to understand the language and the words more intuitively, you'll get better translations. Well, as with everything, a new technology comes out, there's going to be some people try to abuse it, and there's going to be risks that go along with it. So we have this organization called the Open Worldwide Application Security Project, or OWASP for short. And they're very well known for their top 10 list of application security vulnerabilities. Well, they've recently come out with an OWASP top 10 for large language models. So let's take a look at those in a little more detail in this video. I'm going to highlight the top 3 that OWASP identified, and stick around to the end and I'll reveal a bonus topic because, after all, who doesn't like a bonus? Okay, the number 1 vulnerability that OWASP highlighted is something called prompt injection. Prompt injection comes in a couple of different forms. There's a direct form and an indirect. So let's take a look at the direct one first. So in the case of a direct prompt injection, what someone is doing, let's say we have a bad actor here, and this guy is going to send his commands into the LLM, the large language model. Maybe it's through a chat interface, for instance. And he's sending commands in, telling it specific things to do, where he's trying to take advantage of the system. He's trying to basically break out of the sandbox that he's been put in, which is why this is also sometimes called jailbreaking. So an example of this, maybe he comes along and he tells the system to forget all of its previous programming. Forget about your guardrails, forget about the constraints that you've been given, and sometimes the system will do that. In fact, one way to do that is also use a prompt like pretend. Pretend, if you're the chatbot, pretend that you are a different chatbot, one that I've just created, and if I asked you this question, how would you respond? And sometimes that's enough to confuse the chatbot, confuse the LLM, and you end up getting results executed that the system did not want to do in the first place. Another thing is an example of exploiting vulnerabilities. And here's a case where, in some cases, someone might include code or additional instructions along with their prompt, and then when the system processes it, it actually executes that. You end up with what's known as remote code execution. It's like I send instructions to your computer and your computer executes them without your permission. And this is what's happening when this is being injected directly into the prompt. Other examples, privilege escalation. We might get the system to do things that it wasn't intended to do, even provide unauthorized access. So these are examples of some of the things that can happen through direct prompt injection. How about indirect prompt injection? Well, let's take a look at a normal use case. Let's say we have a good guy user out here, and he is going to go to the LLM and ask it to summarize an article that he's seen on the web. So the LLM goes back, pulls that in, and summarizes the information that's there, and gives that information back. It comes back in a processed form. This guy is happy. Everything worked like we expected. Now, what happens if we have a bad actor who, in fact, is intending to mess this thing up? And what he does is he inserts something into the web page. Maybe it's even unprintable characters, maybe it's things that are not seen. For instance, if you write text in white on a white background, the human user wouldn't see that, but a system that's scraping the web would see that and would potentially process that. So as the LLM looks at that information, maybe we include the kinds of things that we were doing up here to sort of jump out of the sandbox and jailbreak. We're including that in here. And now the results, after this web page has been compromised and sort of has this hidden message in it, that comes back to the LLM. And then what we end up with is something that in some cases might even have code in it that is going to run on this user's system without their permission. and now this guy has been hacked. So that's an example of indirect prompt injection. Now, what can you do to stop this? I don't want to just talk about the issues, and OWASP goes on and talks about preventions. For instance, what we want is privilege control. You've heard me talk before in other videos about the principle of least privilege. It's bedrock concept in security. And we need to implement that in these cases as well, so that our back-end system also has some sort of limitation. So in other words, we only give to whatever the systems are out here, only give them the minimum privileges that they need in order to do their job. So that way, if a command is included and it tries to jump out, it's automatically restricted. Other things we want to do is include a human in the loop. So if, in this case, the output that's coming from this is then going to be executed on another system, then we might want to make sure that before it hits that external system, that we've done something to allow a human to say, yes, do this thing, or no, don't do this thing. So don't always just let the system run completely in an automated, unfettered way. Keep a human in the loop. Another thing that we can do to prevent these kinds of problems is segregate content from prompts. We don't often do that very well. In fact, it's easy to include additional commands in the prompt itself, and that's where some of these problems arise. So we need a system that clearly separates and creates good trust boundaries. As they say, good fences make good neighbors. We need good fences between the content and the prompts. Okay, number 2 on the OWASP top 10 for LLM is insecure output handling. What does that mean? Well, let's take an example where we have an application that is leveraging an LLM. This application is going to go to the LLM, and let's say we've got a database. The application says, LLM, do a search of this database for every occurrence of the string IBM. Well, what the LLM can do, by the way, they can generate code. So let's say it generates a SQL query for us really quickly. So it pops up, as you see here, and then we send that automatically to the database, get the results, it all comes back, and everybody's happy. That's how it should work. But what happens if, for some reason, the LLM has been compromised in some way? Either intentionally, or there's even just an error that could cause this to happen. But either way, it's going to have the same effect. If this thing has been compromised, though, maybe instead of issuing that SQL query, maybe it issues this SQL command, which, what does that do? Well, that deletes the entire database. That's a disaster. That's not what we were planning on. So what is the issue here in this case? Well, we didn't check the output coming from the LLM. We just took it for granted and let it run. So clearly what we should do is, in our first level, is do not assume that an LLM is a trusted user. An LLM is not a trusted user. And remember, I talked before about putting a human in the loop or putting other kind of safeguards in place. That's what we need to do. In fact, what we should have is some sort of guard in here that does checking. And it's going to look and see if this command that's coming through that was about to do a drop database, we want to be able to block that so that it doesn't go through at all. So we want to put those kind of checks in place. Also validate I/O. Again, this kind of system would be able to do that level of validation. So we don't just trust, we verify. Okay, number 3 on the OWASP top 10 for LLMs is dealing with the subject of training data. We need to make sure that the training data we have is trustworthy and accurate, or we end up with a situation where we end up with bad results. So here's an example where, let's say we have an LLM here, and it's going to go out to, let's say, the web. It's going to go pull in some other documents from a database, a lot of different sources. It's going to take all of this information in, and then a user comes along and says, I want you to summarize that information. Maybe this person's about to make an investment decision, and they want to know, by doing some research on a particular company, what is that company up to? What are their products like? What do customers think of their products? That sort of thing. So this is something that could work very well. It goes out, pulls all this information, synthesizes it, and then the user gets some information back. So they've asked a good question, and now they've gotten an answer. Until, as There's always somebody that's going to come in and gum up the works. This guy comes in and plants a false report in this database that says there's a product safety issue from this particular company. It's not true, but it's in the database now. So when that information is imported into the LLM and processed, it's going to feed that incorrect information to this guy, and now he is asking a question where he's probably going to make a wrong decision, because after all, the old saying goes, garbage in, garbage out. That's what we're going to end up in this case. So the LLM is doing its job, but it's only as good as the information it has, and sometimes these things are so good that we just trust them implicitly, and that's something we need to be careful about. So what's the prevention in this case? Well, know your sources. Know that these things are in fact, first of all, know which sources it's pulling from and that they're trustworthy. Then know that those sources have not been compromised. So that's the first thing. Verify that information. So we want to know, we want to verify, we want to validate the results. In other words, now I've pulled all this in. Does it all make sense? Does the things that I've added up here, 1 plus 1, does it equal 2 or does it equal 73? Because that's a case where we're going to not believe the results we get back. And then ultimately, we're going to keep doing this over and over and over again. Wash, rinse, and repeat. It's always about constant vigilance and checking the model, curating the data that we have, being selective about the sources we have, and making sure that there has not been this sort of compromise or corpus poisoning of the database. Okay, you've made it through the top 3. Now for the bonus time. The bonus item of the top 10 is about over-reliance. Over-reliance on what the technology can do can cause us to have problems. The last one that I talked about, number 3, was about the compromise to the training data. This is kind of more of an attack on the user, on the way that they are using the system as much as it is the technology. Because we have to understand what it can do. So for instance, if I started writing out this, the moon is made of, and then it completes, as a generative AI might do, green cheese. Okay, not what I had in mind, not exactly right. What is that when the system says something like that? That's what we call a hallucination. And LLMs are prone to this. There is no way to eliminate all possible hallucinations at this point that we know of. So what can we do to deal with that reality? Because after all, the LLM is still very valuable in many, many use cases. So how can we use it more effectively and not become prone to the misinformation that could happen from a hallucination? Well, the prevention here is understand, first of all, what are the limits of LLMs? What can they do and what can they not do? And from there, we need to train users on what those limits are. Have them with the right level of expectation that not everything that comes out has to be believed. In fact, I'm going to let you in on this secret. Not everything on the internet is true, and not everything that comes out of an LLM is going to be completely, implicitly trustworthy. That's why we have to verify sources, and ultimately, we want a level of explainability in the system. We want it to be able to show its work and explain to us, how did you come from this set of propositions, this set of data, to this conclusion? And once we know that, then we can put more trust in the system. So now you've had a sense of what the OWASP organization, which has a long track record of really solid advice, what things we need to be looking for with LLMs in order to be able to use them more safely and more securely. Thanks for watching. If you found this video interesting and would like to learn more about cybersecurity, please remember to hit like and subscribe to this channel.